Hey there, Jambat. By the end of this video, you should be able to understand the heart and the way it works or functions. Now, one of the major function, or the major function of the heart is to circulate blood round the body. Now, in order to understand this circulation and the way it occurs, it is good to first go down the evolutionary history of advancement and complexity in organisms and how it affected circulation. Now, organisms, now we're going through the animal kingdom, so we're going to be starting from the early animals that we call Protoctista. The phylum Protoctista, that will be the kingdom Protoctista, we'll be examining the phylum Protozoa. Is that okay now? So we said proto means early, and zoa means animal. Proto, early, zoa, animal. So we'll go from this level down to the arthropoda. Then we'll go to basically the insects, that those are the arthropods. So the protozoans, the arthropods, are many mollusks. So now, so you know that this order that I arranged is in order of complexity. So protozoans are less complex than arthropods, and arthropods less complex than mollusca. Then we get on to our Pisces, the amphibians, the reptiles, the aves, and the mammals. And let's quickly take a rundown of evolutionary advancements in their method of circulating nutrients or substances internally. Now you see protozoans, because of a very small surface area to volume ratio, they do not need or require organs, specialized organs or systems to transport substances within them. Is that okay? So substances are transported from one place to another by simple diffusion, in fact, in and out of their cell, because in fact, most protozoans exist in the cellular stage. Is that okay? So, for example, you see amoeba, proteus, paramecium, migraina, those guys, when they need substances, in fact, they imbibe them from the environment. Is that okay? So they need not even take it in first and begin to transport, basically because the body surface area to volume ratio is very small, so substances can easily diffuse through their body through their cell membrane into their body. So there is no need for circulation. All right. Now, as we now go down, we're going to meet the arthropods. We're going to meet the annelids before the arthropods, actually. So in annelids and arthropods, we find what is called the open circulation. The open circulation. So circulation can be grouped into two. We have the open and the closed circulation. The open and the closed circulation. The open circulation is when the fluid of transport is in direct contact with the internal organs, or the organs that need this, that needs the constituents that this blood or this fluid is transporting. So, for example, we see in insects exhibit an open system of circulation. Annelids, arthropods, mollusks, and most mollusks, not all mollusks, but most mollusks have an open system of circulation. And what that means is that their internal organs are in direct contact with their fluid, the fluid that transports the substances such as oxygen, such as nutrients around the body. Direct contact, that is open system. This is what I mean. Now, in closed system, we will say that the blood is taken through a conduit, a pipe or tubes that we call vessels. So the blood or the fluid of transport is born in vessels for closed systems. The fluid of transport is born in vessels, while in the open circulatory system there is no the organs that need the blood are basically floating inside the blood. But here in closed system, there is a vessel that conveys the blood or fluid of transport that conveys it to wherever it is needed. All right, so that is open, we said it's common in these two, and then the closed, we see it in all of this, the closed system of transportation. Now, of circulation rather. Now, in Pisces, which are basically fishes, in fishes, we see a different type of closed circulation. Now, in fishes, we see what we call the single circulation. So we have grouped circulation into open and closed. So we know open is when there is the organ is directly bathed by the blood. The blood is basically bathing the organ. So there is no need for a conduit or a pipe or a tubule or a vessel to pass into the organ to deliver whatever the blood needs to deliver to that organ. No, that is the open. But in the closed, the tube delivers it. The blood is born in those tubes. The blood is passed through those tubes to those organs and they deliver whatever they want to deliver to that organ. Now, we now see in species the first type of closed circulation, and that is the single circulation and the double circulation. That will be the major focus today. Now, you see, single circulation is what we see in the blood because it forms only one loop. It forms only one loop. Now, in order for us to understand this, let's quickly cram something. Let's quickly know something. Now, the connection between those tubes are in three systems. We call one system the artery. We call the next system the capillaries. The capillaries. The arteries, the capillaries, and the veins. All right? So, and it goes like this. There is one which takes blood away from the heart. How do I put this? Let me represent this well. So there is one which takes blood away from the heart. So if this were my heart, there is going to be one of these systems, these three systems, that takes blood away from the heart. So this is our heart. One of these tubes takes blood away from the heart, delivers it to a particular organ here, and then from that organ, it flows away, minus whatever the blood this organ has taken from it. So it comes from the heart, plus oxygen, plus nutrients, plus whatever else the blood is trying to give to this organ. So then from here, it goes away through the vein, through another tube, I'm going to name it later, through another tube, and at that time it is minus oxygen, minus nutrients, and other substances that blood has delivered onto this guy. So this system that conveys from the blood is called the artery. And this system that conveys to the heart is called vein. From the heart, artery. To the heart, vein. From the heart, artery. Through to the heart, vein. You get it? So if it goes away from the heart, it's going to be the artery. It's going to be called the artery. And depending on the organ that it's going to from the heart, we will now name them pulmonary if it's going to the lungs. Pulmonary means related to the lung. Hepatic artery. So we have pulmonary, as I mentioned just now. Pulmonary means anything related to the lungs. Then if we said something related to the kidney, you will hear renal. If it was going to the liver, you would hear hepatic. Is that okay? So, and of course, pyrolic for the stomach. So basically, if it is a tube that is taking blood to these lungs, it's called pulmonary artery. Why? Artery, because artery always goes away from the heart, takes blood away from the heart. So it's called pulmonary artery if it's going to the lungs. If it's going to the kidney, it's called renal artery or renal artery because it is taking blood away. Remember, artery takes blood away. Artery takes blood away. Artery takes blood away. So the artery takes blood away from the heart. So if it were going to the kidney, it's called the renal artery. Now, if it were going to the liver, it would be called the hepatic artery. If it were taking blood away, we call it artery. Remember that. Now, this other system that takes blood back to the heart or returns blood back to the heart is called the vein. So if it were taking blood away from the liver back to the heart, it would be hepatic vein, taking blood away from the kidney back to the heart. Renal vein, taking blood away from the lungs back to the heart. Pulmonary vein, back to the heart. I like that, back to the heart. All right, let's go now. So the vein takes blood back to the heart, artery from the heart, blood vein to the heart, artery from the heart, vein. And that's how to remember it. Artery from the heart, vein to the, artery from vein to the, all right, let's go. Now, but there is a system here, a portal here. Let me call it a portal. Let me call it just a system of connection here where that differentiates a bridge, thank you, a bridge that differentiates between the artery and the vein, and that will be called the capillaries. The capillaries are a system, a very tiny system of blood vessels. We mentioned vessels the other time. Of blood vessels, tiny vessels inside the tissue of the organ that the blood is conveying blood. As in, there's an organ here, and the organ is composed of tissues. So these capillary networks are wire mesh-like networks of blood vessels that convey blood. So what does that mean? If they convey blood here, it therefore means it is where the exchange takes place. And that is why the two major important parts of the circulatory system are the heart and the capillaries. The heart, this guy, and the capillaries. We're still going to label this and you're going to see how it's going to go. Now, you see, the heart and the capillaries are the major most important because the heart pumps it, gives the pressure, creates motion on it. Is that okay? And of course, pressure is force over area. So force is impressed on there's an impetus on that blood to move. Hey, move. Who does that? The heart tells it to move. Now. This is now the heart, the capillary. Why is it important? It is because it creates, the French calls it the raison d'etre. Is that French or Latin? I don't even know. Now you see, raison d'etre means the reason for happening. Is that okay? So capillary makes the blood actually have a reason for happening. Circulation have a reason for happening. What is the reason of that circulation? For oxygen, for nutrients, and other things to be transported to a particular organ. So where does the exchange between the blood and that organ, where does that exchange take place? It takes place in the capillaries. So, from the capillaries, as it's going back to the heart, the vein carries that blood, which is lacking in those things that the blood brought before. Do you understand now? So let's go again. We said artery from the heart, vein back to the heart, artery from the heart. All right, let's go. Now, so if that process of transportation occurred in one loop, as we are seeing now, then it will be a single circulation. If it were a loop, in one loop, it will be called a single circulation. Now listen. Let's make sense of this. So let's assume that the blood that was coming here was plenteous in oxygen, had much oxygen, or was oxygenated. We call it oxygenated blood. Let me go through that. Now, this is where you have to listen, really. Listen very well. The blood coming from here was oxygenated. So we call it oxygenated blood. The oxygenated blood comes here. It releases its oxygen. By the time it's going back here, it becomes deoxygenated. It's just a common term, meaning that not oxygen. There is no oxygen again. Is that okay? So the blood returning to the heart is now deoxygenated. Now, where does it get the oxygen back? Because it has to flow again. It doesn't release once in a lifetime and then say, I'm not doing it. It continues. Is that okay? And in fact, when the heart stops, life stops. Do you understand? So there's the circulation will have to go on again. So how does that blood again that has been deoxygenated, how does it get oxygenated again? Now, if it were to flow in one single loop, as we would see in Pisces, in fishes, as we would see in Pisces, if it were a single loop, then it means that there must be one part of this loop where that blood has to be oxygenated again. So here's how a fish oxygenates its blood. Now, somewhere around here, the blood on arrival at the heart, first from the heart again, first goes, takes a visit to the, fishes don't use lungs, except for lungfishes, I mean now. But for teleosts, they use gills for breathing. They use gills for breathing. So the gills are the systems that provide makes oxygen available to the blood. So the blood flows over the gills and becomes oxygenated. It traps or extracts oxygen from the gills. If you have seen my video where I talked about the system, it's a countercurrent exchange. So blood and water flow in different directions so that it might be the extraction of oxygen, and that will go into the blood. Then the oxygen goes into the blood, and that blood continues, does not return to the heart that, oh, bro, I've been oxygenated, so what do I do now? So it just takes up the oxygen and proceeds to where? To the organ that it needs to supply oxygen. Is that clear? Let me take that again. From the heart, it goes to the blood, to this guy, gets deoxygenated, now flows back to the heart, then from the heart again, because it's still deoxygenated, it goes to the gills in case of the fishes and becomes what? Oxygenated. By that time, it continues in its flow and goes back to the organ that it needs to oxygenate. All right, let's go to the next one. The amphibians. Now, you see, so that is why in the heart of the fish, there are only two chambers. There are only what? Two chambers. Their heart is a two-chambered heart. Is a two-chambered heart. And you see, that single circulation is very inefficient. Is inefficient because by the time blood, now let me talk about pressure grading. Now, you see, by the time the blood gets here in the capillaries, the blood pressure is usually higher. So it's usually, because it's a tinier tube, is that okay? So as it's flowing here, it was rushing here. So by the time it gets into that tiny tube, it becomes, because of the loop, and the convolution of that capillary, the pressure reduces. So because of that, before it gets, flows back to the heart, the pressure is lower. Is that okay? That is why in fishes, they don't use veins. I use vein because so that you understand when we get to those of mammals, we call what they use sinuses. So sinus is, we say sinuses. Sinus is a special form of vein, basically, because it returns blood to the heart. So it's a special form that makes sure that the pressure is not lost. Do you understand? It makes sure that the pressure is not lost. That is sinuses. That is how it compensates for the loss in pressure that happens in the capillaries. Now let's talk about the amphibians now. The amphibians, so we said this guy, two-chambered heart. These guys have three-chambered hearts. Amphibians have how many chambered hearts? Three-chambered hearts. The reptiles have three-chambered hearts, except crocodiles. I didn't say alligator. I said crocodiles. You understand? So crocodiles are the only reptiles that have a four-chambered heart. Amphibians, on the other hand, or other reptiles, have what? Three-chambered hearts. Now you see, in the three-chambered heart, or the three-chambered heart, would be the only system where the only circulatory system, or the only form of circulation, where oxygenated and deoxygenated blood mix. However, or albeit, the mixing is not so apparent. It's not very, because if you imagine that, you would think that the system, they actually both mix. There is a system by which the hearts of those organisms are able to separate them. They're able to separate them. In fact, they have what is called the conus arteriosus. The conus arteriosus. Conus arteriosus. So this conus arteriosus is one of the ways by which the ventricle, so there are three chambers, as I said, let me name them. For this one that have two chambers, one will be called the atrium. That's the first chamber the blood makes its way to. Then the chamber below is called the ventricle. Ventricle. So the word vent means where it drains, right? Yeah, so think of it like that. So it just goes from here and then drains into that place. All right, and that's where there's higher pressure to pump out the blood. But my point is this. So those are the two chambers. For these guys, For amphibians, they have two atrium, right and left atrium, and a ventricle, right and left atrium, and a ventricle. And anatomically, we are going to see how it is being spelled out, because sometimes you might think this is the right, and then you confuse it with the left, and think this is the left, and confuse it with the right. So I'm going to show you how to name that. Now, the reptiles also, we said three-chambered heart. So it's basically the same system, Now, aves, from aves upwards to mammals, we have this guy, four-chambered heart. Basically, the mammals are the ones that have the most efficient four-chambered heart. The mammals, they have what? Four-chambered heart that is efficient. Now let's go through how the four-chambered heart works. Let me clean what I have on the board in order to make space for explanation. All right, let's go through the four-chambered heart. A four-chambered heart. Now this is a four-chambered heart, and you're going to see that here's the first chamber, second chamber, third chamber, and the fourth chamber. So now anatomically, now as I'm facing you in the camera, my right is here, my left is here. Is that okay? So if this were my heart, I mean, my heart is not as big as this. Is that okay? My heart is not as big as, yeah. All right, so this is not my heart, but let's assume this were my heart. This side here is going to be my right. This side is going to be my left. Is that okay? That's how we view it anatomically. But when we face it, you're going to see that it would look as though this were our left, and this would be our right. Is that okay? But this would be our right, which happens to be my left when I face it. So we'll call it the right. Remember the first chamber, we said atrium. The right atrium. How is it spelled? Atrium, I think that's correct. Okay? Then the lower one, we call it the right ventricle. And then here, we're going to have the left atrium. And here, we're going to have the left ventricle. So how does circulation happen? Now, here, this guy you see here, now, the heart has a very thick muscle that's called the pericardium. The pericardium. And this is part of one of the muscles that increase its ability to pump or induce pressure on the blood, all right? So my point is this: how does the circulation take place? Now we should know that here it is a double circulation that takes place. So starting from I'm sorry, I forgot to mention that. Starting from the amphibians, we see double circulation, but it doesn't get efficient until it gets to the mammals, until it gets to us. Is that okay? It gets to us. All right. So here, this guy here, this pipe that you're seeing here with an arrow going up. Don't worry, inside of you there is no arrow there. Is that okay? Right. But here, this guy here, this pipe is called the vena cava. Is that okay? Because it is under, it's called the inferior vena cava. If you are saying, if I said, why are you feeling inferior? That's why you're feeling low. Is that okay? So it is low. Is that okay? So that's why it goes into. So it pumps blood into here. Notice it still enters where? The first chamber, which is the right atrium. So this one enters here. Another one enters here because that one is coming from, the heart is here. So there must be some organs that is supplying here. We have the carotid, the one that supplies here. Okay, when you see the brain, when it talks about the head, you see carotid. So carotid, anything, all right? The pulmonary, because lungs is also a little higher where it supplies, is that okay? So we call that pulmonary. So the vein has to come from the top there. So we call that the superior because it's above. You understand? So someone that is above you, what do you call it? You say it's my superior. So superior vena cava. So basically they are the major veins and the one in which the pressure is highest in. Is that okay? The superior and inferior vena cava. So let's start from the below. So this is the leg of the person here now. The blood that is coming from every other part of the body except the lungs. So the blood that is coming from every other part of the body enters here, except the one from the lungs. from every other part of the body, even the brain, kidney, spine, whatever, they enter into here. So the blood flows into here, and from here, it enters into this place. So by the time it enters into this place, which is the right ventricle, it is, now you see these things here. We call this the tricuspid valve. Tricuspid valve. They are called valves. So why are they called valves? You're going to see that they are arched. And the reason why they are arched is so that they prevent backflow of blood. So they permit blood to flow in one direction. By the time the blood is trying to move out, they block it from entering back into the space. So let's go back again. We said deoxygenated blood, basically. The blood that has lost its oxygen or nutrient has come into here from here, and has entered into the right atrium, and then from the right atrium it makes its way to the right ventricle. Now from the right ventricle, it pushes into this guy here, which is called the pulmonary. Now pulmonary, what will it be? Is it taking blood to the heart or away from the heart? Because it is going, look at the arrow is going, you remember that? Okay, let's go. Now you see, because the blood is going away from the heart, away from the heart. That is artery, is that okay? So pulmonary artery, because it's going away from the heart. So the pulmonary artery goes to where? Pulmonary, where's that go? That be pulmonary. The lungs, yes. So it takes the blood to the lungs, and in the lungs, the blood is able to what? Take oxygen and release carbon dioxide, because that was what is exchanged oxygen for before in the other organs of the body. The other organs of the body perform respiration or respiratory activities, and they are given for the waste product of respiration or the end product or the byproduct, that's what we call it, byproduct. So CO2 enters the blood. We call the blood deoxygenated or carboxylated blood. Is that okay? So carboxylated blood will now go through the pulmonary artery to the lungs and take oxygen, become oxygenated, and now the exchange takes place within where we call the alveolar, or alveolus for one, of the lungs. So the alveolus releases oxygen into the blood and takes out, by diffusion also, takes out the carbon dioxide that is there, and that carbon dioxide is being expelled out of your nose like this. Yes or not? All right, so the blood that will now return to the blood will now return through the pulmonary what? Now pulmonary, because it's connected to the where? To the lungs. Vein, why? Because it is returning blood to the back to the heart. Once it returns blood to the heart, the vein, away from the heart, artery. Do you get that? Good. Now follow me. Now you see this. Now when the blood is now coming back to the heart. Now I'm supposed to draw this is the tube, the whole of the tube, or this where it empties through. So it now goes into the heart. This blood now is oxygenated, and in fact you see it is fresher. It's looking handsome. By the time you see it, it's happy. You understand? All right. So the vein returns the blood here, the left atrium. So you will see that there is a distinction between the part that takes oxygenated blood from the part that takes deoxygenated blood, and that's why there is a partition here. It's known as the septum. The septum. The septum. The septum separates between the two chambers. Is that okay? No. It is only the left atrium that receives what? Oxygenated blood. Never the right atrium. The left atrium receives oxygenated blood, and the oxygenated blood flows into the left ventricle. And this guy, remember, is also a what? A valve. But this time we call it the mitral valve. The mitral valve. So the mitral valve does the same work as this. It disallows backflow of blood to the artery. By the time the blood wants to be pumped, remember, now if you look at this place, the muscles are thicker, right? The muscles are thicker. So the pressure in the atrium is less than the pressure in the ventricle. Or you say the pressure in the ventricle is always higher than the pressure in the atrium. So it pumps the blood out through here. Notice there are also valves here. Yes, there are also valves. These valves also do what? They prevent backflow of blood. All right. So the blood will now flow through here. What does this connect to? Let's see together. Okay, let's see. The blood now gets pumped out of the ventricle, and this allows it from going back here. So it now goes like this, goes like this, goes like, whoa, this is called the artery then. Why? Because it takes blood away from the heart again. Do you see that? So it's taking blood away from the heart and it's the major artery of the body. It's called the aorta. The aorta is the major artery of the body. And then I forgot to tell you this also, because before we get to the capillaries, which is the branching network, the artery begin to reduce its size, and as they reduce, we begin to have what we call arterioles. Then veins also starts from the venules. Venules are tiny, tiny veins. Arterioles are tiny, tiny arteries. Is that okay? So this guy flows out, flows to different parts of the body this way, and continues to branch and branch and branch and branch like that until it gets to the different organs that need the blood, the oxygen in the blood, and then those organs take up the oxygen, give carbon CO2 to the blood again, and then return in the same loop, and the system starts all over again. So you're going to notice this is coming down. This is also the aorta. Is that okay? All right, and that is all for circulation. Please do well to subscribe to the channel to show me that you got all that I explained here. Now, I am not done with that question, but by the time I'll be finishing this video, uploading the video, I'll be done with it. So I'm going to link a test in the description to test your comprehension. Is that okay? So you can take the test. Just click on the link, and the password and all will be provided in the description below. See you next time. God bless you.